Okie dokie. So continuing on, we're going to talk about the more secondary structure of our DNA, and specifically talking about the DNA double helix, and we'll get into replication soon. I did want to start off with a little bit of a history lesson. To be honest, this was kind of shocking to me too. I learned this before, but I didn't really put it into perspective until I was prepping this for you guys, and I was like, whoa, this is kind of crazy. So our history lesson on structure, the secondary structure of DNA. So DNA was discovered in the 1940s. So the actual molecule itself was not discovered until the 40s. So all they knew about it is the structure of nucleotide monomers. So they knew what the monomers were. They knew the general structure in that the monomers connected via phosphodiester bonds, but they didn't know how it actually like coiled together like we know now, the structure of DNA. Additionally, they just found out that DNA was what carried our information, our genetic information, not proteins. So the primary sequence of DNA is not random, it is very specific. So in 1949, DNA was isolated from various organisms, and this was the first time that base pairs were talked about. So in our nucleotides, there's specific pairs. So purine bases equal or have a specific pairing with a pyrimidine base. So A is going to bond with T, C and G are going to bond with each other. So they found when they were looking at different DNA samples that there was always an even number of purine bases versus pyrimidine bases. In 1952, Rosalind Franklin used X-ray diffraction techniques. So this picture here is from Rosalind Franklin. So Franklin and Roshing, I think. But they used X-ray diffraction. So they shot X-rays at so really high energy light at a molecule or a nucleic acid of DNA. And they got this picture, which suggests that DNA is a helix. So they took that X-ray and they magnified it and got this diffraction pattern. So Rosalind Franklin was the first person to suggest that DNA was a helical shape. And then in 1953, James Watson and Francis Crick proposed the double helix structure. So based off of this, they made a model of what they thought DNA looked like. And that's the same model that we use today. Their actual model that they made, like physically made out of like metal and wood and everything, is in a museum in London, I believe. If you're ever in London and you want to see it. So between the two of them, or the two different publications, and then one additional one, I actually looked up these papers because I was really interested to see really like what they talked about and how things were talked about in the 1950s. And they have 3 back-to-back papers in the most high impact science journal in the world. 3 back-to-back papers. The first one was James Watson and Francis Crick. The second one was Rosalind Franklin and I don't remember who else. There were like 2 other names on it. And the last one was with this guy, Wilkins, talking about RNA structure. So in 1962, the Nobel Prize in Physiology or Medicine was awarded to Francis Crick, James Watson, and Maurice Wilkins. You'll notice that Rosalind Franklin is left out. She was the one who actually came up with the helical structure to start with. But unfortunately, she passed away from ovarian cancer from all of the different X-rays. So all the different X-rays caused a genetic mutation in her own DNA and caused her to get cancer. So you cannot get a Nobel Prize if you've already passed away. You can't do it. You can't get one after you passed away. So Rosalind Franklin was the one who didn't get it. So it was a little bit of it's actually made a lot of people angry in the science community, thinking that they should have awarded this earlier and given her a portion of it as well. But what really stuck out to me too, this is really cool to me to talk about the history of it, but really what really stuck out to me is that people who are still alive today are like, they were born and grew up without knowing what DNA was. So, for example, I talked to my parents a couple days ago and asked how old was my grandfather in 1953 when they fully discovered and published the structure of DNA. How old was my grandfather? And he was 19. Like, my grandfather was 19 years old when they figured out what the structure of DNA is. How like recent is that? So thinking about all of the different technologies that have come out of knowing the structure of DNA, like, it's cool that it was really just so recent that this um, was discovered. So I just think it's crazy. My parents responded with, so does that mean that grandma and grandpa don't have DNA because they were born before it was discovered? And I'm like, haha, no. But um, they're just making jokes. But to me, it's just kind of crazy to think, like, what if when I was 19, something really big happened and I just didn't really notice because I was just kind of chilling, going about. So I don't know, this is just really cool to me. So I hope you guys enjoyed my little history lesson about DNA, and we'll get more into the actual structure of DNA in our next video.